Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon for all participants. We try to discuss about some properties, the next properties for the new probability model, namely Power Rado Institute distribution. We have success to talk the some properties already, like the density function, cumulative function, survival function, hazard function, and we try to make the very clearly explanation by using the sum, for example. And then for this time, we will continue our discussion about the next properties, such as the first and the second moment. Okay, this is very important properties. Maybe with these properties, we can find the variance of the Power Rado Institute distribution, because we know that the variance equal to the second moment minus the first moment power 2. Okay, now we can check our candidate books. Okay, from our candidate books, I always say the candidate books because you know the reason. The reason is the book still in the process, and I don't know when will be finished. Okay, in these books we have discussed about the first and the second moment. The first moment, it's mean we take the expected x. Expected x, it's mean the integrated starting minus infinity until infinity, x multiplied by the density function. So if we talk about the Power Rado Institute distribution, of course, the first moment is the integrate starting 0 until infinity, x multiplied by the density x. Okay, this one x, and this one is of course is density of the Power Rado Institute distribution. We have already discussed about the Power Rado Institute distribution density function. Now we try to find the first moment by using the integrate starting 0 until to infinity x multiplied by the density function of the Power Rado Institute distribution. Okay, we take the outside from the integrate for the constant. We know that's alpha multiplied by theta power k divided by summation starting I equal to 1. Starting I equal to 1 until the k function gamma I power theta multiplied by theta power k minus I integrate until 0 starting 0 until infinity x by summation. Okay, by summation I equal to starting 1 until k x multiplied by I multiple x x power I multiplied by alpha minus 1 exponent min theta x power alpha. So we try to, with the simple mathematics, this first moment you can find like this one. Okay, so after we have this form, okay, we try to make the 3 partition for the integrate. This one, the first part, and this one for the second part, and the last one, this is the last part. Of course, we must solve for the each part. We try to solve one by one. Okay, for example, we try to solve the first parts. So it's mean we will try to solve this integrate. Okay, so if we take mu equal to x power r, and of course x equal to nu power 1 divided alpha, this alpha x divided x power alpha, if we take nu equal to x power alpha, and of course x equal to nu power 1 divided alpha. And the x, of course, du divided by alpha multiplied by nu power 1 minus 1 divided alpha. So we try to change x by the nu power 1 divided alpha. Okay. So this one x, we try to change by nu, okay, power 1 divided alpha. And the x, we try to change by the d nu divided by alpha multiple nu power 1 minus 1 divided alpha. So this all integrate, okay, with this the simple mathematics, we can take this is the outside from the integrate because this is constant, 1 divided alpha constant, and this one is integrate, and this one it's mean this is gamma. If we try to solve this the density gamma function, okay, this is gamma function with this is gamma function. So of course this integrate, so very easy. We can solve by the 1 divided alpha multiplied by gamma function 1 divided alpha plus 1 divided by theta power 1 divided alpha plus 1. And of course, with the simple mathematics, we can solve this problem with the gamma function 1 divided alpha plus 1 divided by alpha theta power 1 divided theta plus 1. So it means the first part, okay, we successfully solve this integrate by the gamma function 1 divided alpha plus 1 divided by alpha theta power 1 divided alpha plus 1. And next, we come to the second part. The second part, we will solve the integrate starting 0 until infinity, x power 2 alpha exponent min theta x power alpha. So, if we try to change by this component, for example, we give the nu equal to x power alpha and x of course equal to nu power 1 divided alpha, and of course the x equal to d nu divided by alpha nu power 1 minus 1 divided alpha. So of course the integrate is a very easy. You will solve this integrate by gamma function 1 divided alpha plus 2 divided by alpha theta power 1 divided alpha plus 2. And of course, for the last part, with the same way, okay, for the last part, with the same way, with a simple mathematics, you can find the result of the integrates equal to gamma function 1 divided alpha plus k divided by alpha theta power 1 divided alpha plus k. Also very easy. So after we are success solve this part, okay, we try success solve the integrate for this part, for the first part, for the second part, and for the last part. So we try to solve this integrate. Okay, we try to solve integrates by changing this one with this first part, and the second part we change by this one, and the last part we try change to which one. Okay. So now our integrates, of course, well, this is very easy. With the simple mathematics, of course, we can find the first moment summation I starting equal to 1 until k, gamma function 1 divided alpha plus I multiplied by theta power k minus 1 divided alpha minus I divided by the summation I starting to 1 until to k gamma function I multiplied by theta power k minus I. So it's very easy. So it's mean our first moment only depend on what is the K, okay, about the K, only depend on only about what is K. K is mean the number of mixture, okay? And then, of course, for the second moment, we only try to find the expected x power 2. Okay, for the expected power 2, we only need integrate 0 until infinity x power 2 multiplied by the density function. Okay, the density function, this one is density function for the power Rado institute distribution. Okay, we try to solve the integrate with the make the three partition like we are solve the first moment. With the same way, we try to make the three partition for the integrate. Okay, this is for the first partition. This is for the second partition, and for this is the last one, the last for the partition. So of course, we try to solve partition for the each partition. We try to solve one by one. Okay, for example, we try to solve for this first partition. Okay, this one we solve for this for the first partition. With the same way, we try to let u equal to x power alpha, and it means x equal to nu power 1 divided alpha, and of course dx equal to d nu divided by alpha multiple nu with power 1 minus 1 divided alpha. So this is integrate, so it's very easy with the simple mathematics. And of course, after you change this x, you change this x, and you change this dx, so we can find the integrate is equal to gamma function 2 divided alpha plus 1 divided by alpha theta power 2 divided alpha plus 1. This is the result of the integrate for the first partition. So next we come to the second partition. Okay, we will try to solve this integrate. With the same way, of course, we must change x by nu power 1 divided alpha, and you try to change dx by d nu divided by alpha multiple nu power 1 minus 1 divided alpha. You can find this result become the gamma function 2 divided alpha plus 2 divided by alpha multiplied by theta power 2 divided alpha plus 2. This is very easy. So of course, after we are success solve the second partition, next we come to the last partition. For the last partition, with the same way, okay, it's the same way, we will try to the simple integration, and then we can find the result. For the last partition, it's gamma function 2 divided alpha plus k divided alpha multiplied by theta power 2 divided alpha plus k. And then after we are success to solve the three partition, the integrate of the three partition, we will find the expected x power 2 or the second moment with the simple mathematics. You can check here in the candidate book. You can check in the candidate book. This is the first partition, the integrate per partition. Is the integrate of the second partition. This is integrate of the last partition. With the simple mathematics, we can find the second moment is equal to summation I starting to 1 until k gamma function 2 divided alpha plus I multiplied by theta power k minus I minus 2 divided alpha divided by the summation I equal to 1 until k, okay, gamma function I multiplied by theta power k minus I. So I think this very, very important to understand that if we have the general form for the second moment, and we have the general form for the first moment. This is the first moment. Okay, this is first moment. This is for the first moment, the general form for this moment. And this one is the general form for the second moment. So after we have the first and the second moment, if we have the density function of the power Rado Institute distribution with the special K, with the various K, maybe the K equal to 2, 3, 4, and X, we just only use this formula to find what is the first moment and the second moment. Okay, I think our discussion today is a very, very nice discussion with this, with a simple soft skill to solve the integrates. We can find the general form or the general formula for the first moment and the second moment of the power Rado Institute distribution. Okay, for the next session, we will try to using this general form to solve the some density function, especially to find the first and the second moment. Okay, see you again, Rado Yendra and Rado Institute. Assalamualaikum warahmatullahi wabarakatuh.